Hi, I am Catherine Moore, and I am one of the co-chairs of the PMIx Administrative Steering Committee, or ASC. My other co-chair is Josh Hersey, and I am delighted to kick off this 2020 year-end video that will tell you all about what we have been doing in the PMIx ASC this past year. The PMIx ASC is a formal body that we have formed that has the goal of improving and developing the PMIx standard. We currently have 13 member organizations that are shown here on this slide. But this is an open organization, so if you are interested in joining our ranks, any entity can become a member, and by entity we mean an organization, or if you are not affiliated with an organization, for example, you're a retired person, you can join as an individual. The ASC has quarterly meetings where we have a formal voting process that helps us make major decisions about how the ASC is governed and changes to the PMIx standard. We also have monthly meetings that are a lot more informal, and their goal is to make sure that we are making forward progress. So things we do at monthly meetings are things like getting feedback on any proposals we might have to make sure that we're going in the right direction before the next quarterly meeting. And if you are interested in joining us, please check out our governance document. It will tell you all the details that you could ever want to know about how our body works. And now I'd like to introduce you to the current PMIx ASC leadership. For co-chairs, the first co-chair is Josh Hersey from IBM, and I, Catherine Moore, again, am the other co-chair. I'm from Lawrence Livermore National Laboratory. We have two secretaries. The first is Aurélien Boutayev from UTK and Thomas Naughton from Oak Ridge. Then we have two release managers who are responsible for helping us schedule and plan the major releases of PMIx, the standard, and those are Ken Raffinetti from Argonne and David Solt from IBM. The PMIx ASC has 4 technical working groups right now. The first is the Implementation Agnostic Document Working Group, and that's a whole lot of words, but what that means is that this working group is working towards making sure that the language in the document does not imply a specific implementation of the standard API. So we want anyone to be able to implement this however they need to for their system. And this is led by David Solt from IBM. The second working group, led by Stephen Herbane of Livermore, is called the Slicing Grouping of Functionality Working Group. And their goal is to bring out use cases and classes of uses of the PMIx standard to facilitate usage and understanding of the standard. The third working group is the Dynamic Workflows Group, led by Jay Dial, and here we're looking at how PMIx can facilitate and support dynamic workflows where processes may come and go during runtime, or maybe resources are allocated and deallocated to the job. And then finally, the storage working group is led by Shane Snyder from Argonne. And in this working group, they're examining how PMIx can help tools that manage I/O or other kinds of data on systems that have different kinds of storage devices. So we can query the system, find out what storage devices are available and what their capabilities are. As I said earlier, our goal is that anyone can implement the PMIx standard, but currently there is one publicly available implementation of PMIx, and that is Open PMIx. And if you want more information or you want to download and try it out, please go to their GitHub page, github.com/openpmix. And we do welcome and encourage other implementations of PMIx. If you're interested in this, but not sure how to get started, not sure how to get involved, please contact us. Adoption of PMIx is increasing every year, and this year is no exception. So there's a wide variety of users of the interface, from resource managers to runtime libraries, for example, an MPI and OpenSHMEM, as well as tools. So now that the interface is becoming more standard on different systems, we see tools beginning to rely on it, from debuggers to I/O tools to tool infrastructures and container implementations. And now I will hand off the talk to Josh Hersey, who will tell you about the status of the standard itself.
Thank you, Catherine. As we're all well aware, 2020 has been a challenging year for everyone. I cannot express how much I appreciate all the hard work the PMIx community gave to this project, despite these challenging times, to achieve everything that you see here and on the next slides and throughout the presentation today. This list does not include the specific work of the working groups, which we'll present in just a moment. We had a number of PMIx standard document releases and OpenPMIx software releases this year. On the PMIx standard side, we continue to refine our governance structure as we clarify and streamline the process. We saw 3 release versions of the governance document, with the latest being v1.3 released in July of last year. We also had the v3.2 minor release and the v4 major release of the PMIx standard this past year. PMIx v4 marking the major release with a number of features such as those listed here, but certainly not limited to that. On the implementation side, we saw a number of releases of the OpenPMIx implementation of the PMIx standard, the latest of which is the v4.0.0 release in December that matches the PMIx v4.0 standard, also released in December. This includes quite a number of improvements, including those listed here. The OpenPMIx community is committing that the major minor version release numbers will match that of the corresponding PMIx standard. And this is to help users know which version of the PMIx standard interface they're using. This will also be printed in the version string emitted from OpenPMIx. Additionally, in 2020, we've started working on membership in SPI, Software in the Public Interest Organization. This will provide us some legal support, the ability to hold things like domains and a common trust, and a common means of paying for any community required needs such as domain registration or management of reimbursements for face-to-face meetings, those kind of things. This should help us organizationally long term. There have been some website changes as we move from a WordPress to a GitHub pages. The goal here is to make it easier for the community to maintain these sites. They are, as all websites, a continual work in progress. If you don't see the information you're looking for or have an idea for some content that would be useful to provide, please reach out to the community or file a PR. We saw a couple new sub-projects emerge. The MPIR shim project, they are designed to help tools transitioning from the MPI-specific old MPIR protocol to a library-agnostic PMIx tool interface. Recognizing that the MPIR interface will take a while to phase out, a shim layer is useful to have for launchers interacting with tools that have not yet made the transition to PMIx. This source code and associated documents are meant to help tools and launchers make the transition to PMIx while maintaining backwards support for this MPIR protocol, which is widely used right now. The PMI shim project exposes older PMI1 and PMI2 interfaces to the user, which is helpful for client libraries that have not yet made the transition to PMIx. These shims convert as much of the PMI1 and 2 as possible into backend PMIx calls. The code for this project used to reside inside of OpenPMIx and could be enabled or disabled via a configure option, but we decided to split it out into a separate project to focus the development effort around it. So we've achieved quite a bit in 2020. Looking forward to 2021, these are our big guiding goals that we hope to achieve this year. We're working on a PMIx standard v1 that'll include some errata items and a few provisional items. Minor releases in this series come as fast as every quarter to improve the consistency of the document and present provisional items for community develop-based feedback. The release managers for the v4 series are Ralph Castaigne and myself. We are also hard at work on the PMIx standard v5 that will include some text additions and clarifications to improve the readability and usability of the interface. Things such as use case descriptions and a refined introductory material in certain chapters are all on development for inclusion in v5, as the working groups will probably talk about in just a moment. Additionally, any provisional items that have been elevated to stable status will make that transition in a major release. Major releases move at a slightly slower pace given their scope, but we're working towards a release of the V5 standard later this year. The release managers for the V5 series are Ken Raffernetti and David Solt. As we continue to work under the new governance structure, we find places that need clarification or streamlining. As such, we expect to see a few more minor revisions to the governance structure as we move forward through the year. Updates could be released as fast as once a quarter, depending upon the need. All proposals need to go through 2 major votes, given their impact on the community. The PERTE project is meant to be a place to experiment with a resource manager that provides the server level support for the PMIx standard. This project is working towards its V2.0 release in the first half of this year, which will be a production ready release that OpenMPI v5 has committed to including in their release series. With the support of the PMIx and OpenMPI communities and other communities using PERTE, we plan to create a runtime environment that's stable enough for established products, yet flexible enough for experimentation. The OpenPMIx implementation of the PMIx standard will continue development, matching its external interfaces to that defined in the PMIx standard, while innovating in the internal plumbing and new interfaces moving forward. We hope to complete our membership in SPI or similar organization this calendar year and start moving assets into that structure for the community to use as a whole. As the community grows, so do the interests in seeing how PMIx as a conduit between libraries, tools, and resource managers could benefit their domains of development and research. We will establish working groups in areas of interest to investigate these refinements and additions to the PMIx standard to support these communities. If you have an idea for a working group or an interest in helping establish one, please reach out to the co-chairs. The PMIx community has expressed interest in forming a working group around tool and debugger interactions and on hybrid programming. We hope to get these working groups started this year. If you're interested in joining that discussion, please reach out in the mailing list. Now let's turn to the working groups for their individual presentations on what they've been working on and what they will be working on in this next year.
Hi, this is Dave Solt, and I'd like to give you a update on what the PMIx Implementation Agnostic Working Group has been working on the last year and where we're headed in the year to come. So this working group was created to help ensure that the standard document was not specific to any particular implementation. To understand that, you have to understand a little of the history. We've kind of started with an implementation, and then the PMIx standard followed. And much of the text of our current standard has kind of evolved over the course of time from that initial implementation. And so we really wanted to make a concerted effort to separate those out and make sure that the standard was a standard document and that it was open to new implementations, and that it didn't assume anything about how an implementation was made or force a particular method to implementing some of these APIs. So our working group has been meeting for over a year now, and our regular attendees, Josh, Catherine, Swaroop, Martin, myself, we've also had some other folks, Ralph, and others have attended occasionally or attended at request. We have a mailing list if you'd like to join that to find out information about our meeting times especially, but we do meet Mondays at 1, and if that time is not good for you, we have moved it in the past to accommodate folks, so please let us know. So I'd like to go over our accomplishments from the last year. It was a pretty busy year. Kind of three main things that we worked on was a rework of Chapter 1. We made modifications to Chapter 2, a lot of clarifications there. And then we also brought several issues up to the community, many of which, I would say most of which, were incorporated into version 4 through efforts outside of our immediate working group. For Chapter 1, we did a fairly extensive look at that chapter. It's obviously very foundational. It lays the groundwork for what's to come, and it tends to have a lot more prose in it than some of the chapters that are API specific and more simply listing parameters and return values and that sort of thing. This text is a little bit more flavorful and really needed careful attention. So we looked at introducing PMIx in terms of what it is, what we want it to be, rather than simply as it was previously introduced, kind of as its historic evolution through PMI. We did keep the PMI information, but moved that to a background section. We did some work on consolidating some of the presentation around the optional nature of both APIs and attributes to make that a little bit more coherent, consistent. And a lot of work just to clean up the document, make it read as a standard document rather than as a user's guide. We also avoided introducing or looking at specific APIs unless it was very clear what they did, to try and defer that until after they have been introduced in the document. We also generalized the document a little bit to not be so HPC specific, but to open it up for other use cases in distributed computing. Chapter 2 was also an involved effort. There were actually 2 PRs that we did for this one. One focusing more on the organization of the chapter and the introductory text, and then a second PR that really looked at each of the terms that were introduced, and some of the issues we brought up to the community that did not necessarily result in PRs directly from this working group, but were incorporated in many cases into version 4, are listed here. The first one, the state of return codes. I don't think this really has been fully addressed. The fact that there are many return codes in the standard, but there's not a lot of guidance on how they should be used or when they should be used. And so if you're making an API call, you don't really know what return codes you could expect from any particular API. So that's not something that's really been fully addressed yet. Some of these others have. The idea around required attributes, what that means for an attribute to be required for an implementer versus the idea of a user marking an attribute as required for their specific API call. So there was some confusion there, and I think a little bit that has been simplified. A lot of the issues we brought up there, I think, have been addressed. There's also clarification around the initialization and finalize functions. And so much of that has already gone in, and we do have one PR outstanding I'll mention, I think, on the next slide. And we also started a fairly large effort to look at the presentation of how data is shared through PMIx get, put, fence, and to some degree publish and lookup. And a lot of that feedback that we made and issues that we brought up have been incorporated into the version 4 of the document. And there are other things that we're continuing to work on. I'll explain next. So that brings us to our 2021 ongoing effort, and that is this major rework of chapters 6, 7, and 8, and to some degree chapter 9, which is published lookup. But for the most part, chapters 6, 7, and 8 focus on data access and sharing, particularly get, commit, and put. And the key concepts there around reserved versus non-reserved keys and how those are handled differently. And the areas, or what we've been calling, what we've been referring to as data realms in our latest draft, are these ideas of that a key can be for a process, or it can be for an application, a namespace, a session, or a node, for example. And so we want to really carefully present these ideas since they are very important to what PMIx offers. So moving forward, we have a number of things going on. We want to finish off a PR clarifying the 3 roles of consumers in the PMIx interface. This is something that came from that initialization, finalization effort I spoke of earlier. We want to continue and hopefully finish our organization and study of chapters 6 through 9. And then another thing that came up during this discussion that I haven't mentioned yet is, a kind of follow up on the best way for implementations to introduce new attributes to API calls, or introduce new values that can be gotten with PMIx get that are not standardized, but perhaps they want them to behave, the implementation wants them to behave in the same way as the reserved keys. So what is the best way for an implementation to handle that? So it's something we're going to be looking at, I think, going forward. Hopefully when all of that's done, our long-term plans are to continue through the remaining chapters, continuing to follow our charter. One of the things involved in that, we've kind of skipped over the chapter that presents structures, types, constants, and that sort of thing. And we do want to look at what the best way is to present that, whether it should remain standalone or be presented kind of along with the APIs at the most appropriate place. That's another study we'll take a look at. So I hope that this has been a useful update on what we've been doing. And if any of this sounds interesting, we would love to have you join us. We're a pretty laid back group, and certainly none of us consider ourselves experts in either PMIx or the standard, but we are learning as we go, and I think making good contributions. So feel free to check us out. Thank you.
Hi, I'm Steven, and I'll be giving a summary of the Functionality Slices Working Group, what we're working on, what we did in 2020, and our plans for 2021. But first, I'd like to thank Josh and Swaroop, who have been attending the working group for the past year, and everything I'm about to present in these slides they've made possible. So thank you both. So our working group is focused on helping solve the problem of finding PMIx components necessary for a given use case. So given the size and the structure of the standard, it can sometimes be difficult to figure out exactly which interfaces and attributes for those interfaces you need to use for your particular use case, especially when you need to use interfaces that cut across multiple chapters in the standard. So we want to provide a mechanism for focusing in on the aspects of the standard that are of interest to a particular use case. And we specifically are going to accomplish this by creating an appendix with a list of high-level use cases and the PMIx APIs required to support them. So in 2020, we went about creating that appendix with the most common use cases that we identified. In particular, Bootstrap or business card exchange, which is the exchanging of information between parallel processes so that a parallel runtime can start up, whether that's MPI or something like OpenSHMEM. Next, we tackled debuggers and tools, and that particular use case actually has a lot of sub-use cases because it turns out there's a lot of different ways that you could want to debug a parallel application. Maybe you want to attach a debugger to an already running parallel application, or maybe you want to launch the parallel application directly on a debugger, for example. And so we cover all of those sub-use cases within that broader use case. And finally, we also tackled hybrid programming models. In particular, how programming models can declare themselves when PMIx initializes, and how callbacks can be run for the declaration of other programming models, so they can identify each other and then synchronize to avoid deadlock. So we posted a provisional PR for reading and voting at this quarterly with that appendix, and it covers approximately 20% of the client-side interfaces in the standard. And unrelated to the appendix, we also met with several representatives of the power community, looking to see if there was interest in standardizing APIs and attributes for controlling power on nodes and on accelerators. And the outcome of that was it's probably still too early in that community. They haven't really converged on a single solution yet, and so we're going to wait a little bit longer so that PMIx doesn't end up picking winners, and instead let the community sort of converge on a solution first. So our plans for 2021 are to investigate additional use cases. This includes MPI sessions, inspired by the prototype that's in OpenMPI, and I think the broader use case there is sort of having dynamic groups and group membership where processes can be added and removed at runtime. The second is instant on, which is sort of an alternative to business card exchange, so that rather than exchanging all the information as the first step in a parallel runtime's execution, this is all sort of done beforehand so that the parallel runtime can boot up immediately. There's the cross-version compatibility issue that pops up, particularly with containers, where the host operating system may be running a different version of PMIx than the container. There's fault tolerance, which is a bigger and bigger topic these days. And then the last two use cases we would like to do in collaboration potentially with other working groups. So a tiered storage use case in collaboration with the storage working group, and workflow management in collaboration with the dynamic workflows working group. So the second thing that we have planned for 2021 is if our provisional PR gets accepted, we will be updating the use cases to keep them in line with the changes that are happening in the standard. And then our third plan for 2021 is to extend the existing use cases, the three I mentioned previously, with the server-side APIs. And so we think this will actually be really beneficial for new resource managers that are coming in looking to implement adopt the PMIx, the Open PMIx implementation, so they can know exactly which server-side APIs they need to implement to support various use cases. So if any of those things interest you, we would love your help. In particular, we would love feedback on identifying use cases that we've missed. If you didn't see a use case you have in mind listed in the previous two slides, please open an issue on the PMIx standard GitHub. There's a use cases issue template that you can use, so that will get labeled appropriately, and then we can iterate from there. We would love help documenting use cases. So if any of the use cases in the previous slide interest you and you want to help document them and add them to the appendix, let us know. And finally, if we can get any feedback we can get on the existing documented use cases would be great. So check out our pull request that's up for review right now. And even if that gets merged, if you have time to check it out after it's merged, we would love feedback on how to improve it. So if you want to help, you can subscribe to our Google group mailing list, the PMIx Forum Working Group Funk Slices. Our weekly calls are Thursday at 9 a.m. Pacific time. Every month, there's one conflict with the monthly meeting, and so we obviously don't meet during the monthly meeting. I'll send out the WebEx info through the mailing list, and if you subscribe to the PMIx calendar, you will not only get the quarterly meetings and the monthly meetings, but you'll also get our working group meetings on your calendar. So, thank you.
Hello, my name is Shane Snyder, and I'm a software developer at Argonne National Labs. I'm generally interested in storage and I/O research topics, and I'm also the PMIx storage working group lead. Today I'm going to provide a quick update on what we've been up to in 2020 as well as what we plan to accomplish in 2021. Our mission at the storage working group is just to extend the PMIx standard to support interaction with HPC storage hierarchies. This could be for applications, for I/O libraries, for job schedulers, things like that. Basically just providing them the interfaces they need to interface with storage. We've identified a couple of key APIs that are going to be necessary to enable storage-aware PMIx applications. The first is an API that allows you to discover available resources and learn about them. Turns out that this API can actually be satisfied by existing APIs. Specifically, there's PMIx query and event notification APIs that we can integrate into to provide this information to users for storage systems. The second interface is a more active storage system management interface that allows you to direct storage systems to do some sort of task. So as an example, you could direct storage systems to stage or unstaged data to or from some other spot. And this is obviously entirely new APIs that we'll be contributing to the standard. One of the challenges we've identified so far is how to come up with suitable abstractions for storage concepts, especially as HPC storage is kind of in the process of changing a bit. So one thing in particular is how to account for traditional file-based storage versus emerging object-based storage systems like DAOs, which are going to be used on next-generation systems. So one of the challenges is how we account for that and the APIs we propose. As far as current working group stakeholders, we've got a lot of representation from different storage teams that are relevant in the HPC community. For storage system teams, we've got input from Lustre and Deos. So they represent some of the perspectives of large-scale, facility-wide storage systems that are available to users. On the other hand, we've got involvement from Mochi and Unify teams. These teams are more involved with data services, which are a little bit different than something like Lustre or Deos, in that they're deployed alongside jobs by users. So they have different perspectives that we think will be valuable for the storage working group going forward. We've also got involvement from I/O libraries and middleware teams, so MPIO and Veloce. Veloce is a checkpointing library. We've also got involvement from PMIx library implementers, and they're really helpful for helping us think about how to implement some of the things we propose. That said, we could certainly use more help. So if you're interested in storage-related topics, or maybe just wanted to get more involved in the PMIx community, please don't hesitate to reach out to us. We'd love to have you contribute and get involved. I've got some information down here about our meetings and our Google group, and I've also got my email if you want to reach out to me directly. But again, if this is something that you think you might be interested in, please don't hesitate. As for what we've been up to in 2020, the working group actually just kicked off right at the beginning of 2020, so we're relatively young, but we've actually been making some meaningful progress so far. So we started off by just evaluating the existing PMIx API to determine where we might be able to integrate in existing places. And this was really useful for kind of getting our bearings within the standard and things like that. And it steered us towards my next bullet, where I mentioned that we extended the PMIx query interface. So this is to extend PMIx's existing query interface to allow support for querying details about storage systems. I'll go over these in a little bit more detail in the next slide, but these extensions we have a first cut basically wrapped up, and we'll be presenting them at the quarterly meeting in a couple of weeks, so that they'll hopefully be able to be integrated into the standard in a provisional state, so people can start looking at them and giving more feedback. Lastly, we implemented some initial OpenPMX storage system query support. For storage query support and the PMIx standard, again, this is something that we really just viewed as a logical starting point. Applications likely are going to want to learn more about what storage resources are available for them before they start trying to get storage to do things for them. So we view this as being really important. So over on the right, I've got just a sample storage hierarchy that's representative of HPC, and some examples of storage queries that we'll be able to answer using PMIx is what storage resources are available, so which of these different layers of the hierarchy do I actually have available to me, how do we access a specific storage resource, so for like a file system, what's the mount point or things like that. What are the capabilities of the storage system? Does it have can it provide a peak or observed bandwidth, so I have some sort of expectations on performance? And what is the current state of the storage system? Is there available capacity? Things like that. And again, this query capability we think is going to be really kind of a fundamental building block for building portable storage-aware PMIx applications. We've also developed a prototype of the PMIx storage query interface in OpenPMIx, like I mentioned. Our initial focus has been on defining a common VFS query plugin, and that is responsible for answering some really simple common query requests for POSIX-based file systems. So specifically, it's using get mount int and statfs calls to provide details on file-based storage or POSIX file-based storage systems for users. So this is helpful so that we don't have to re-implement this code for GPFS, for Lustre, for XF, all kinds of different file systems. So we have a single plugin that can answer all these simpler query requests. Beyond that, we'd like to, and we haven't started with this really yet, but we want to move on to storage system specific query plugins. So you can imagine providing a Lustre query plugin, which is next on our to-do list, that can answer a little more detailed queries that the VFS one doesn't know how to answer. Or you could come up with entirely new plugins for things like Deos that could answer Deos specific queries and things like that. As for next steps for the storage working group, just kind of continuing from the last slide, but we definitely want to shore up our OpenPMIx storage query implementation and get that merged into their master branch, just to make it more generally available. And then we want to start investigating implementing a subset of more specific storage system queries for Lustre, just to kind of follow that thread a little further. We also want to augment PMIx event notification interface, as I mentioned, with storage-related events of interest. So some ideas that we've kicked around are notifications about storage errors, notifications about nearing capacity thresholds, notifications about idle or overloaded I/O resources. And last but not least, we want to develop new PMIx APIs that allow more direct control over storage systems. So this would be, as I mentioned on my first slide, an interface to do more direct actions to storage systems, like stage data from, or I guess the first example would be for like storage reservations. So like the Cray data warp system at NERSC for burst buffers, how the PMIx storage interface could be used to make storage reservations that jobs then use. And similarly, related to that would be how to control data movement between storage tiers. So after you've got your burst buffer allocated, how do you define interfaces for staging and unstaging data to and from it? Those are some topics that we're very interested in pursuing. But I think that's it. That's all I have. So again, if you have any feedback or questions for me, please don't hesitate to reach out. Also, if you're interested in getting involved, don't hesitate to reach out to me. But yeah, that's it. I appreciate all of your time.
Hi, my name is Jay Dale, and I am a software engineer at Intel. In general, my interests lie in the intersection between systems and HPC applications and workflows. And I'll be talking to you today about some of the progress we made in 2020 with the Dynamic Workflows Working Group, and also what our plans are for 2021. Our working group, generally has a couple goals that we're trying to accomplish. Really what we're trying to do is take a look at various dynamic workflow applications and runtimes and see how well the PMIx standard, can hold up in light of the requirements and desires of these applications and workflows. So a lot of what we're doing is investigating these use cases and seeing how well the standard holds up, and then where we need to, we're trying to define uh, augmentations and attributes and stuff like that for the standard to better meet the requirements that these runtimes and applications need. And also on top of that, we're also trying to increase the adoption of PMIx across the workflow community. We feel that this would actually be beneficial because one of the problems that we run into is a lot of HPC centers don't really offer applications and workflows real dynamic capabilities. So we feel if we have more of these runtimes equipped with PMIx, we feel like it would make a stronger case to some of these HPC centers to really enable some of this dynamic functionality that a lot of the resource managers have. In our working group, we have a number of participants and stakeholders, and their interests range from dynamic task-based runtimes all the way up through scripting languages for dynamic workflows. And a lot of these stakeholders have given various tech talks and use case presentations to our working group. Just listing here some of them that we've seen over this last year. This isn't an exhaustive list; these are just some off the top of my head. So don't feel bad if I left something out. But just Adios is one, Balsam, Radical, etc. And we've evaluated these technologies in light of PMIx, and in general, PMIx actually does a pretty good job of meeting most of the requirements that these workflow engines need. So that's a good thing. But we've also found a couple gaps and some things that we've been able to fill and some other areas to explore, um, further. And in general, we're always looking for more people. So if anyone has an interesting use case that you think may be relevant to our group, just feel free to chime in on one of the later slides. I think the last slide I have all the working group information, the mailing list and contact information, that kind of thing. So just some current highlights for things that we've gotten done in 2020. One is that we've increased the PMIC adoption. We've gotten SwiftT from Argonne. Now uses PMIx to spawn additional worker tasks. Previously, they were using some kind of mechanism basically to talk to some job script in some service nodes and that kind of thing. But now, they're directly using the PMIx spawn to kind of make some of that go a little bit easier. Also, from Rutgers, there's a Radical Pilot task runtime, and they actually presented some performance problems that they came across with PERT-A, and we were able to kind of get those fixed. So later PERT-A releases had some of these performance issues addressed. In terms of the PMIx standard, we looked at GPU attributes, and we've defined a number of GPU attributes that would enable runtimes applications to reason about the GPUs on the system they're using, and also give them a regularized, standardized way to specify GPU affinity requirements. For 2021, our agenda really is going to be picking up this Adios and Savannah use case. And we're gonna, right now it doesn't use PMIx in any way, shape, or form, but they have an interest in running on various exascale machines. And PMIx is gonna be, on Aurora, and they plan to run on Aurora. So this is a good opportunity for them to use PMIx directly and actually have their application, their workflow ready to run on Aurora. So for a lot of this year, we're actually going to be going through this use case and figuring out where we need to add PMIx and adding PMIx where we need to, and then figuring out how we need to change the standard and that kind of thing. Moving on to, one of our things that we talked about was GPU affinity. Really, the motivation for this is that a lot of these applications and actually kind of do a lot of hard coding with their GPU selection in the application. At best, they do some kind of rank-based calculation to pin, to assign GPUs to different processes. But this gets a little bit harder in the dynamic case because when you're in a dynamic workflow, you don't actually, your resources aren't static. They may grow and shrink over the course of the run, so you don't always know which resource you're going to get or when you're going to get it. So being able to expose, GPU affinity and that kind of thing to higher level workflow planners and give them a regularized way to kind of specify the affinity for this makes some of this process a little bit easier. We looked at a number of different things in our group and specifying how do we want runtimes to specify GPUs. Do we want to leave things general for affinity, like say just give me something close to me, or I don't care which GPU give me. You can even give me a GPU in another socket, or give me a GPU in a NUMA domain, those kind of things. So we've try to capture as many of these desires as possible. Here's just kind of a quick list of some of the attributes that we've had to define. I don't need to go too far in depth in some of these, but basically through these things here, you'll be able to query and reason about the GPUs on the system. You can look at the number of GPUs available on a node or on the in your job. You can try to get how much GPU memory is available, and you can set various affinity policies that we talked about a little bit before. So you can check the standard when these are finally added to the standard. You'll be able to check there and get more information on these things. Our plans for 2021 are to use this Adios and Savannah runtime to really kind of get a concrete implementation using PMIx. PMIx will make this process a little cleaner, less bug prone, and make it a little bit more portable than what they have now. Kshitij Mehta from Oak Ridge is actually going to be joining our working group and is going to actually be starting to do the development from the ground up. We kind of have a high level plan of how we're going to do it. We're going to use PMIx initially to just launch a very static workflow, just get that piece up and running, and then we're going to use PMIx to change the components of the workflow. So we're going to keep the resource allocation fixed, and then we're going to change which components are operating in this resource, on this pool of resources. And then we'll get to the more elasticity case. This one's kind of a challenge for us because there aren't too many HPC centers that allow for real elasticity. So this, presents somewhat of a, there probably are some, but the ones that at least I have access to don't allow that to happen. So, we have to come up with some ways of dealing with this. One is we could fake it in PERT, basically let the user allocate the max, 100 nodes up front, but only give them 50, and then, give them the remaining 50 when they request them. We can play those kinds of games as needed. But this will allow us, to evaluate our work, and also being able to have a concrete implementation done of a dynamic workflow that really does try to use resources dynamically. Being able to have a real case makes it a little easier to present to HPC centers to get them to enable this type of functionality. A lot of the job schedulers and resource managers out there do have this functionality, but a lot of HPC centers disable it. So we'd like to get them to not do that. And here's just in general our working group info. You can email me if you're interested, or you can check out our Google groups, and there's also an agenda that you can check out here as well to see our upcoming topics and talks or that kind of thing. Okay, thank you.
Wrap up our year-end presentation, I would like to again thank all of the PMIx community members for their contributions to the PMIx standard and associated implementation projects. If you're interested in learning more about PMIx or getting involved, follow the links above, reach out on the mailing list, or listen into one of our upcoming meetings. Thank you for all of your hard work in 2020, and I'm looking forward to what we can accomplish in 2021.